Hello, welcome, good evening, and welcome back to the BS and Beer Show. Of course, BS stands for Building Science. Tonight's topic, rectifying common building deficiencies. I'm Travis Brungard, and tonight I am drinking not one, but two Free State Guavatas, delicious sour beer. I got some of these for you, Ben, when you're coming to Kansas City in a few weeks. BS and Beer is an independent grassroots movement to share building science knowledge through local meetup groups and this, our Zoom show. The brew crew and our guests volunteer our time each month to bring you what we hope is a fun and informative discussion. If you're interested in starting your own BS group, we encourage that, and you can find advice on how to do that at thebsandbeershow.com or ask one of us. And I'm not ignoring your email person from Texas who just emailed me about starting a group. There is one in Austin, and I will reply to your email. I want to thank Green Building Advisor and also Fine Home Building, who are our wonderful media partners. And then I will pass it off to my esteemed colleagues.
All right. So I have brief announcements tonight. I fixed the chat box. You should all be able to introduce yourself, tell everyone you're here. Please pick either all panelists and all attendees or everyone when you respond in the chat box so that people know that you're here. That's the only way other than the panelists that anybody in the audience knows that you're here. So introduce yourself, tell us what you're drinking. Tonight, I am trying a woodchuck hard cider sangria, which is gluten-free. So we're giving this one a whirl. Not too bad so far. So thumbs up. It's unfortunately fall season here in Pumpkinhead and all those other things are out. And I'm not ready to get on that train yet. So we're still doing some summer things.
Isn't it still August?
No, it is now September 1st. September 1st, but still I'm not ready. No pumpkin spice lattes, no pumpkin beer for like at least another month. I'm not ready. So Fine Home Building sends out a Zoom reminder every month when we do this. All it's going to tell you is that we're going to have a show. If you want to know what the show is going to be about, go over to the bsandbeershow.com, join the mailing list. That'll tell you who our guests are, what we're going to talk about for the next update. The video recording of tonight's show will be up on YouTube, usually by Sunday. So if you missed the show or you want to capture this show and share it with your clients, your friends, whomever, feel free to share from YouTube the past episodes of the show. And there is also a link for audio only version. That's the worst way to capture the show. Join us live. That's the most fun. But if you want to capture that, there is a audio version as well. So off to Mike for actual special announcements.
Thank you, Emily. I am Mike Maines in Maine. I refuse to accept that summer's almost over, so I'm drinking a Beefeater and tonic, gin and tonic. And once that's gone, I have a Spindrift here waiting in the wings. For announcements, we have Helm Construction Solutions in collaboration with Chris Crass is hosting on September 20th an opportunity for men in the construction industry to talk about how patriarchy and toxic masculinity affect their work and lives and how they can build healthy culture within their businesses and workplaces. It's a 2.5-hour session over Zoom with lots of opportunities for one-on-one and small group conversations. It's guaranteed to be an interesting and good learning opportunity. I'll post details in the chat box. The title is, Ben will post it in the chat box. The title is Building Healthy Culture, the Dumpster Fire of Patriarchy. I do want to welcome some of our newest BS and Beer local groups, Orono, Maine, Sacramento, California, Austin, Texas, Cincinnati, Ohio. Josty from Cincinnati is on the call, is on the Zoom, is in the audience tonight. So we'll post links to their Instagram handles in the chat box, so give them a follow and please share when they post, so to help spread the word. And if you are interested in starting a group, like Travis said, let us know. It really couldn't be easier. I would like to congratulate Travis and company for selling out their Midwest Building Science Symposium. It's very exciting. There are still spaces available for the Southeast Building Science Symposium in Chattanooga on October 12th and 13th. And registration just opened for the Texas Building Science Symposium, November 9th and 10th. So be sure to check those out and go to whichever one is closer or feels good to you. But Chattanooga is the next one coming up after Kansas City. The symposiums have had rave reviews, and thanks to sponsors, the registration fee is really quite a bargain. So you want to sign up while you still have a chance. And I will turn it over to Ben for guest introductions.
Sure. Good evening, all. I'm Ben Bogey in Connecticut. This evening, I'm drinking a Kent Falls Surroundings, which is a spontaneously fermented ale with raspberries. Right up your alley, Trav. This eve, we're lucky to have two great guests with us. Doug Horgan is Vice President of Best Practices at BOA in Washington, D.C. He was a carpenter, then got into fixing problems on their handy person warranty team. He has seen and fixed tens of thousands of house issues, and Doug says that each one teaches something. And I'm not surprised, because every time I get to have a conversation with Doug, I learn something. So, Doug, pleasure to have you. What are you drinking this evening?
I've got a Silver Branch Oktoberfest, and someone else in the chat is also having a Silver Branch, which blows me away.
Weird synchronicities. Also this evening, we have Randy Williams. Randy has been in the construction industry for 25 years, 10 of which were spent working as an electrician. In 2009, he moved away from general contracting into career as an energy auditor. Today, in addition to conducting energy assessments, he does some building science and energy design work, and keeps his hands in the carpentry field as a subcontractor and occasionally as a consultant. How are you, Randy? What are you
doing?
drinking?
Well, I am drinking a local brewery, Clockow Brewery. It's a Angry Arms. It's a what is it? A cream ale. It's pretty good. Thanks for having me.
Happy to have you. So, we're going to talk about rectifying common building deficiencies. How do we rectify common building deficiencies?
Well, first, you got to identify them. Yeah,
Flash me.
exactly. Flash me.
That's great.
Doug, do you want to go first? You got a pretty good presentation.
Sure, I'll go first, because I don't want to have to follow you. I can't wait to see yours. All right, let me fire this thing up. Yeah, I mean, I think, well, all right, hang on a second here. I think I should have done this before you asked me to start talking. All right, I'm going to share my screen.
If these are photos
Can
of
someone
my
let me
job, I'm
share
going to be
screen?
ticked.
I'd like to pull up some slides. I don't have a great, I can't really just talk. I just do pictures basically. Just last week, I took my 250,000th construction picture, which that doesn't count ones I take on vacations.
I fixed it so you can share if you
Thank
couldn't
you.
share.
So
Sorry,
I
it's on me.
have a few. Let's see. Wow. Okay. What are you seeing now? Good stuff.
Yes.
Looking
Okay.
good.
All right. So yeah, I think this is the official title, right? Building failures and how to avoid them. I think it's snappier to just talk about how to do things wrong. So let me get into that. One of the best things to do is to don't put drainage and drying space behind claddings that absorb water. So that way you can really soak a lot of water into your rim joist material. I think that works really good. Another way to make sure you're building wrong is you can have good drainage and drying, but just keep pouring water in the top of it. I've now seen this probably 4 or 5 times. You know, people who built with really good drainage, but then they just basically, if you make it so the roof constantly puts a little spritz of water in every time it rains, you can really make things fall apart quick. One of the most important rules for building wrong is don't lap things so that water is directed out of the building. So you want to tuck your house wrap behind your roof flashing so the water goes down into the roof. Otherwise you want to have a building failure. Another great way is to not help people coordinate when they're doing something complicated and it's 2 different trades. So, just let them each do what they feel like, and it'll probably get you something like this. And these are how to learn about stuff, right? You really want to learn what's gonna work right. Do things wrong first, and then that'll teach you a lesson. And these are the things I have definitely done. If you're building a shower, just waterproof the floor and don't really worry about the curb or the walls or the benches. I'm sure Randy can talks to that to a great extent. You can see in this one, this really helps because then when you want to change the tile, there's no curb left because the termites ate the whole thing. Just get a good water source in there. There's a lot of good manuals out there, but they're really a waste of time. Don't bother. Any material sticks to any other material. You don't have to think about that at all. Yeah, so I think it's fair to say that water where it shouldn't be is the main thing that, if you wanted to make one general statement, this is the thing that I see causing the most trouble on jobs. Provided you don't burn a house down or anything, which we've only done that once. I think it's, there's a lot to say about that. There's so much to say about it. I think I've written a couple dozen articles for JLC and Fine Home Building, and most of them are about that. So it's not something that I can talk about in 10 minutes. I'm completely incapable of talking about something not in detail. So sorry. Instead of really talking about all that stuff, I'll just point you to, the BOA YouTube channel or Journal of Light Construction, Fine Home Building, Green Building Advisor, and there's 100 other buildingscience.com places to learn a lot about that. And I'm happy to talk about it too. But it just doesn't feel right for a building science show. For a building science show, we want to talk about something else. So I'm going to do a little thing called My House Sucks, and where I get to use a manometer to quantify how much my house sucks, because manometers are really cool. Okay, so here's a little case study. We got a phone call. Some clients had, there's something weird happening on their basement ceiling. There's like a lot of mold and mildew, peeling paint and stuff. So I cut a hole in the ceiling and I looked up in there, and what are we seeing here? Got some stuff growing,
Microbial
right?
growth.
Microbial growth. You got it. Probably 3 different kingdoms of microbes growing in there. Okay, so what's causing that? I'm looking around. What are some of the options? Actually, I'll give a quick starting clue. Right above it is a line of ductwork, and it's definitely been soaking wet in the past. So there's water dripping off this ductwork. We got this phone call in like July. Important clue. So anyone have any thoughts on where that water might have come from that got on the duct? Go ahead.
So the warm, moisture-laden air from the interior of the house was migrating up through the drywall and hitting the cold surface of the metal ductwork, condensing and then dripping onto the drywall.
Good. This is probably an air conditioning season in July here. I don't know what it's like in Minnesota though.
What's air conditioning
season one day, or it's Tuesday, July 22nd. That's it. No, so that would all be right. So obviously there could be a lot of sources. Interior air during air conditioning season, probably drier than most of the other air around. Yeah. Although if the basement had an unfinished floor, or there's a lot of reasons why a basement might be very humid, but this one wasn't.
Some attic leakage, some
Rim joist
outdoor air.
leakage.
Rim joist leakage. Yeah, you're on the right track. So there's a lot of ways you can get water into a house, especially into a cavity like this. There could have been like a pipe leak in there, or there could have been any kind of basement issue that was connected to this space. But what it turned out to be was outside air, which in our area is incredibly humid in July, was coming into this cavity, and then the water was hitting the humid air was hitting that cold duct, and the water was condensing out and dripping on the ceiling. Okay. So
let me guess. There wasn't, and I'm sorry to interrupt. There wasn't an air barrier preventing dramatic stack effects sucking air in at the. Oh.
Yeah. Yep. Yeah, well, you're on the right track because we're going to be talking about the two things you need to make a leak. You need a hole and you need a driving force. This is the incredible simplification power of buildingscience.com. Yeah, so a house like this, especially, you can see part of this house was built probably in the 1800s. And it's a leaky building. We actually did this whole big thing right here is an addition that we did to it, and that's why I'm there, because they're our clients. Now, what can you tell me about this structure? Is there going to be anything weird about it compared to some other ones?
The underside of it's going to be outdoor temp. So
Yeah,
you're
right,
insulated on all
yeah. So,
sides.
yeah, I mean, I'm skipping a step here, but just talking about a whole kind of different part of the house that's having a similar type of problem. One of the things with a roof like this, a gambrel framed roof like this, is that the inside of the room is kind of shaped like this. So there's these weird triangular areas on each side where it's not really an attic, it's not really a roof, it's not really a wall. So it's I've found that people tend to get confused about what's inside and what's out when you have this weird little space. At least in our area. I mean, from the things that Randy shows on his his Instagram, if you built houses here and moved them to Minnesota, people would know right away. Like there's so many problems with the way that we build, but we can kind of get away with it because it's not 30 below. Okay, so upstairs in that space that we built, there's these weird things going on. Signs of moisture everywhere. I got schmutz around all the electrical and the central vac outlet. I actually had rusty water dripping out of the ground plug on one outlet. That's not normal. So we realized we had some kind of weird problem with this house, and weird problems mean pretty soon you have an infrared camera and a bunch of building science guys running around looking up at everything and trying to figure out what's going on. So you might even have a blower door there. I mentioned this house is leaky. Like many of the houses that I test, we could not get it up down to 50 pascals pressure. It's very unusual for me to pull out a second ring on a blower door test. This one we got down to 37 pascals negative. So we're running around in this. This is the gambrel edition. A lot of the typical things were leaking. At this point, it's cold outside, so I'm looking at cold air coming in. You can see the end of the beam not sealed to the drywall. Even though the light bulb itself is hot, there's a lot of cold air shooting out from it. So kind of typical stuff you'd see on a mediocre build. In our defense, this was like 25 years ago. We're using a pressure pan to measure the pressure in things that are on the exterior walls. And we're realizing that they're very well connected to the outside, the electrical plugs, the ductwork, stuff like that. So that explains the holes. We have a lot of holes, but what's pulling air through them and making the moisture drop out and making all that stuff grow and the rust form in the outlets? As mentioned, we need a leak. You need a hole and a driving force. So we've got, we went up in the attic and we found one of these, a very typical installation around here. People think their attics are hot. They need to vent their attic. They need a fan to blow hot air out of their attic. And these fans do blow hot air out of the attic. There's always a question, which is where's the rest of the air coming back in? And on this house, it was not a vented attic. It was an attic with no vents in it, except for this fan and this fan and this fan. Someone decided that 3 fans were better than 1 and they put 3 exhaust fans on this house and an exhaust fan on one of the fireplaces, probably because when you tried to light a fire, air was blowing down the chimney like a madman because of the 3 attic fans sucking all the air out of the house. So that was the issue with this house. There's a lot of holes. That's on us. And there was an incredible driving force with these 3 fans and the fireplace thing sucking air out of the house. So what was the solution? We closed up the holes the best we could in a finished structure. and we turned off the attic fans. And the way that was the best to close up the holes, because of the expensive finishes on the inside, was actually to take the outside apart and access these crazy little triangle things and seal them all up from the outside, which is so hard to believe. But I don't know if you saw that really cool tile backsplash. That thing was expensive. Yeah. Incidentally, when I put this into PowerPoint, the alt text was a building that has been destroyed. But it said with low confidence, but I just want to say we were in the middle of fixing it. We destroyed it for sure, but we were going to put it back. Microsoft. All right, so here's another house, another plug with rust and junk growing on it. That's kind of a weird one. Again, summertime issue. So when I get mystery phone calls about stuff in July, I'm definitely thinking, I know where there's one place where there's tons of moisture. I still have to look for the shower leak and the condensate pan leak and the roof leak and the wall leak. But anytime you can get a bunch of air to move through from the outside and then hit air conditioning temperature, it's going to dump off a bunch of moisture. So I'm always thinking about that. On this one, seemed like the best way to access this room has wallpaper. So we decided that removing the baseboard would be the next step to see what was going on inside the wall. And there's a bunch of terrible stuff growing on the back of the baseboard. Yuck. By the way, Ben, that's that Makita driver with the electronic controls you recommended so highly. Thing's beautiful. Okay, so now I'm trying to figure out what's making this air move. And I can get out the fancy tools, but just a quick thing to mention. I've often used this trick. You just drape plastic over a thing. I was trying to figure out if the part of the house with the bad electrical outlets was more negative than the rest of the house. So I just put a piece of plastic across the opening between them, and sure enough, the air starts sucking in. So I know there's something going on in this part of the house that's driving force. This part of the house is negative, even with respect to the rest of the house. It's pulling air through the opening between the two. This is really cool to use for fireplaces. Sometimes people, it's hard for them to understand when you're telling them that their fireplace doesn't work because their house has a problem. If you put a piece of plastic in front of their fireplace and it sucks into the house, then they get it. It's also a good way to tell when you fixed it. Okay, so in this picture, I'm using a fancy manometer on a much fancier carpet to check what's going on with the house pressure. And it's a windy day, so I'm using like every tube I own. I've got one going to one side of the house and one going to the other side of the house, and then they're plugged together to that green one. And what I'm learning is, on average, this house is running about 5 or 6 pascals negative compared to outside, which is, 5 pascals isn't a huge amount of force, but that is a large amount for a sustained amount of time on a house to be negative. So it's a very nice house. You can just tell by the carpet. So I'm trying to figure out what could be driving this. It actually turns, it's not that leaky of a house. It's a house that we remodeled some of. Well, part of the really nice aspect of this is that this house, they have an ERV on every air handler in this house. And, it's a pretty efficient house. I think they have an air handler for like every 2,000 square feet. And so they only have like 10 or 15 air handlers. So they have like 10 or 15 ERVs. And it's kind of hard to find holes in the walls for that many ERVs. So they put a bunch of them up on the roof. And you're supposed to have 10 feet between inlets and outlets per code. So these 3 are all inlets, and the outlets are on another part of the roof. And we started, actually HVAC guys kind of figured this out. They said, you know what, something's wrong with the inlets on these. What is it? So we climb up there, and it turns out that someone took a lot of time and attention, bought some very special stainless steel screening and soldered it to these copper caps. And in the ensuing few years, it just completely plugged up with debris, pollen. I actually would love to know what this actually is. I think it's mostly pollen, but it could be anything. I mean, people around here mow their lawns like twice a day. So it could be
pollen,
grass.
and then probably algae growth and stuff like that from
yeah. That's a good one though, right? Yeah, so there was a relatively easy fix. First of all, we yanked the screens and we put in 1/4 inch mesh, so it should happen like once. It should take much longer, hopefully. And then we actually balanced everything. You know, those ERVs have taps right on them. You just hook up a manometer here and here, and it'll tell you, are you balanced or not? So that was that one. Can't fix the holes. The holes are very small in that house, but we fixed the driving force. Okay, here's another house. It's July. Hey, can you come over? My housekeeper's cleaned this mold off the ceiling twice. It's still coming back. What's wrong? This is a powder room in the middle of a house, and it's a big house. It's like 25 feet from this room to anywhere on the outside of the house, except that, you know, it's on the first floor, it's above a finished basement, and then in every other direction, it's like 25 feet. So, of course, I'm trying to like I've checked everything with a moisture meter and a thermal camera. There's no signs that there's like water dripping on one spot of the ceiling and that stuff is growing on it because there's a water leak into the drywall. So I'm starting to think maybe there's air coming through this bath fan. So pull out the manometer again and use a pressure pan, which is just a sealed box. Actually, I forgot how expensive these are. They're like $200. It's crazy. And I just did another BPI training, and the guy there was using like Sterilite boxes from Target, and they work just as good. That's all it is a sealed box. You just push it up against whatever you want to check. And now in this green tube is hooked up to the space inside the pressure pan. So I'm getting the pressure in there. And then the manometer here, I'm measuring between the room pressure and inside of that pan. And it's 4 pascals negative inside the room. So the room is trying to suck air out of the fan. And in fact, the room is trying to suck air in from outside. The whole room is negative compared to the outside. So that's this other tube I got running outside. Not very, but a little. And so I wanted to check and make sure it wasn't that whether it was the fan or the cavity around the fan or both. And it turned out it was both. So I actually, instead of using the pressure pan, this time I'm sticking the thing into the cavity. So I decided to cut a hole and look down, and here's following out from the bath fan. So I know there's air coming down this cavity and trying to push into the room. So this is what I did, but I want to hear what I should have done instead. This, in my defense, this was a while ago, and it's probably working reasonably well, but it's really not that pretty, and you know, a lot of stuff not to love about that. Ben, is there some kind of like 16-inch tape I could have used? Swedish
Absolutely.
or Swiss tape?
It would have been like 400 a roll, and you would have
Yeah.
used about 2 feet of it, and the rest would sit on your shelf for the next 7 years until you
No,
finally
I'd do like
figure it
Randy
out.
and stick it on things and see if it stuck.
Or like Tim Euler and wax your calves with it.
Right. Oh, ugh. That sounds painful. Yeah. Okay. Well, that's how we blocked off any air moving through that joist bay. But we had to do something with the fan too, right? So we went out to where the fan terminated, and wait, where does the fan terminate? It's not this. This is this bathroom right here. Yeah, it turns out that like, you know, 85% of the bath fans that were installed from 1985 to 2010 around here, it's just sort of pointed at the soffit vent or the ridge vent. No termination, no damper. So we actually sawzalled out the soffit, and it was a sawzall, not an OMT, because it was an old guy like me. And we found the end of the thing, and we put a cape damper, which is like a fabric damper, on the end. And those are, you know, I guess those are great in high wind situations. They're quiet, and you know, basically the fabric sucks in and closes off. But we found that did not work at the pressure and flow rates that we're experiencing on this fan. So we actually tested it, right? We put the thing on and we ran inside and put the pressure pan up, and it just wasn't blocking the flow at all. So we ended up using a spring-loaded butterfly damper, and there's a particular brand that I've found that because it seems to work just fine, I just keep buying those. It's a Fantech RSK4, but we popped one of those in the end and problem solved. So that one we fixed the hole. So what was making this house negative though? What's the force on this house? Well, let me just talk about that real quick. I won't make it a mystery. It's not a mystery. Okay, so if you're blowing wind on a house and you have more holes on the windward side and less holes on the other side, you're going to get 2 airs in on the windy side and only 1 air going out. So what's going to happen to the house? It's going to get a little bit positive in pressure, right? You're blowing more air in than out, and then it's going to start leaking air everywhere. It's going to be pushing air out of all of the holes. Okay. What if you have more holes on the other side of the house and the wind is sucking air out faster than it's blowing it in? Then your house is going to go negative and you're going to start sucking air in, right? Yeah. Okay, then we have the famous wintertime effect when your house is like a little hot air balloon in a cold sea and the air is really trying to get out the top. You get a positive pressure at the top of your house and a lot of air leaks at the top of the house through all the framing holes. And if you have ductwork in the attic, which you shouldn't, but you probably do if you're around here. And it's negative at the bottom. And all the air that blew out the top blows in the bottom and makes your toes cold and makes you mad. So that's stack effect. And this can be really strong. This working 24/7, 365 can really move a lot of air. But there's another thing that can happen in the many, many houses that we remodel with complete air handler systems in the attic, which is when you turn the fan on, you get a little bit of air leaking in through the 12 or 15 feet of return ductwork to the central return. And then you get a lot of air leaking out of the 250 feet of ductwork going out to all the outlets. So if you have 6 airs leaking out and only 1 leaking in, what's going to happen to your house? Yeah, it goes negative. Yeah. And then it starts sucking air in everywhere it can, including your bath fans and your electrical outlets or whatever you want, whatever you got. So this is the kind of thing that we run into a fair amount around here. And you know, there are solutions, but it's a little bit challenging. We've been doing a lot of aero sealing on ductwork, which does seal ductwork very well. It's gotten to be kind of expensive, but you know, these folks can usually afford that. The one thing that we've had that's kind of a hassle is that it turns out that if your ductwork's undersized anyway, and your air handler is, you know, your system is teetering on the ability to fail already from lack of airflow. If you tighten up the ductwork a lot and you cut out 25% of the airflow, which used to be leaks, then you can make your system fail. So you got to be a little careful with checking that first. Mechanical effect. All right, well, let me wrap up with this. This is not what I do all day. What I actually do all day is try to get the effing sub that I've worked with for 5 years, who has seen this picture, who's been trained 50 times to put the effing through flashing on the effing lintel that they just put in. Why am I still having this conversation with them? The answer is he hired a new crew, and I'm around here, we're swimming against the tide. We want things done per code, or maybe even a little better, instead of as worse as we can get away with. And those guys did not think that we wanted through flashing. So that's what I'm doing all day long. All right, that's how to build wrong. Hope that's helpful.
Spoken like a true grizzled professional.
LOL.
Doug, imagine
Groundhog
if we
Day's
had some
approaching.
sort of test for duct leakage or something like that we could use, or like
Oh,
some
I've
sort
heard
of
of that.
standard
I've
that
heard
we
that.
could use to like model duct design or something. Wouldn't that be amazing?
That would be really cool. Yes, you can even test existing ductwork and see how your static pressures are. It's another fun manometer trick. It's kind of surprising. I don't know what to say. I guess people have important things to do and not that, because it's pretty unusual to find an HVAC person who owns a manometer.
We just have to wait till the 2021 code is adopted, the energy code is adopted by everybody, and then it's required. Everybody's.
Oh, that's been required for new work around here for quite a while.
Yeah, it's probably the
Yeah.
same problem that Doug has with his flashing details. So he still has to get them to commit to actually doing it.
Well, and I'm working on a lot of houses that are 10, 20, 30, 50, 150 years old. They can be in any condition. So there are good people out there. I don't want to throw all HVAC people under the bus. And most of them who don't have the time to do stuff, they literally don't have time, right? They're scheduled for 12 calls on a hot day, and they're not going to be checking the stupid static pressure. So there's reasons.
Doug, a few audience questions. Just I think we usually hold questions to the end, but I think where you just did an excellent presentation, by the way. I really like your graphics. That was some good stuff. Our friend Bill Robinson asks, are there any issues with supply and return ducts causing additional negative pressure?
Absolutely. Yeah, I mean, I think people have glommed onto this. If you, particularly in a standard built house where you might be scheduled to blow 100 or 150 cubic feet per minute of air into a room, if you don't have a return pathway from that room, it can go pretty positive. And then when you close the door. So if you do that on a few rooms, then the rest of the house goes negative, and those rooms are very positive and can cause all kinds of air leaks that way. Yeah, and you can just throw your manometer under the door, shut the door, and see what the pressure difference is. Go ahead, Don.
The architects don't want to see jumper ducts and stuff like that over doors, and they also want the doors to go all the way down to the flooring with an 1/8 inch reveal. It's like, well, where do you think this air is going to go?
Yeah. Do you have you tried Tamarac's return air grill, or what do you recommend for that situation? Jumper ducts or a return air grill, or undercutting the doors? What's the best approach?
I have some thoughts, but I bet there's some other people. Well, I'll just throw out like one thing that I learned from John Semmelhack is if you built a high performing enclosure and you're only blowing 40 or 60 CFM into a room, then a normal door undercut is perfectly adequate. Mm-hmm. So that's good news. We do a lot of dedicated returns. If you have all this stupid stuff in the attic, one more line doesn't do anything.
Right.
But and even jumper ducts that are just a piece of flex running between the room and the hallway, that attenuates a lot of sound. I've never tried that Tamarack contraption. That's the worry I would have about it. Has anyone tried that?
I've installed them, but not in situations where it matters or where sound matters a lot. It's really just two grills with a little short piece of ductwork and some corrugated cardboard that goes in the space. It's extremely low tech.
Yeah.
I think it probably blocks a little bit of sound versus just having a hole in the wall. Our audience member Lisa Holderness asks, did I hear that ERVs have taps and that you can check air balance? Is that a thing that all ERVs and HRVs have, or is it special to a certain equipment?
I don't know all the ones I've ever installed do. So maybe Ben's shaking his head, so I guess not.
No, they don't. So Zender doesn't have front taps like most of the other ones out there in the market do, but it senses balance, it senses static on its own, or most of the newer versions do. But yeah, I like the 4 ports on the front to check your 2 air streams. But most of them do.
Yeah.
I've had good luck with that setup. Mm-hmm.
Yeah, and I have a related question. Are there ERVs, can some or all ERVs, and HRVs, can you adjust them so you can sort of compensate? Can you have them blow more air in than they're taking out, or vice versa, depending on the situation? Usually depressurization is a bigger issue. Can you set them so they're positively pressurizing the house, or is that a bad idea?
Really, you'd want it on a calendar so it goes positive in the summer and negative in the winter, right?
Right.
Yeah, that's a great question. I think there's a lot of talk about that. In fact, Panasonic just came out with one where you can dial in so that it will automatically bring more air in or blow more air out, depending on how you set it. And there's even, where did I hear this? there's someone who's talking about a really cool system that does makeup air for range hood vents. So it essentially super ramps up the inlet when it gets that call. So I think I would watch this space. I think people are thinking along those lines, and there's people coming out with solutions. What are you?
It's coming.
Yeah.
Yeah, we use what is it, Electro Industries makeup airs, where it you can program it to sense the current draw across the CT, so it will actually ramp the damper and blower up to match the exit air that's going out from your dryer, your range hood, or your bath fan, or something like that.
Wow, that's cool. Yeah, we've never gotten into
interesting
that.
little thing about door undercuts. So a 5/8 door undercut on a 3/0 door is approximately the same size as a 6-inch supply duct. So if you make a 5/8 undercut on a 3/0 door and you have a 6-inch feed into that room, you know, in high performance houses, I could talk about if we're only pushing 60 CFM, 50 CFM to a room, then just, yeah, 1/2 inch undercut on a door is adequate in order for that room to stay neutral.
Good stuff.
Nice.
Actionable information, Ben. I like that.
Until they
Look
put
that-
carpet in.
Yeah, I always
Right,
go with the full
exactly.
inch.
Yeah, it's funny to think that door undercuts could be like a key aspect to your house's performance.
For comfort.
If we think it's hard to keep people changing filters and equipment they don't know they own, wait till that becomes critical.
You know what you
Oh,
do? You
yeah.
just cut it and you don't give them an option.
You don't tell them why it doesn't touch the floor. It's fine. It's
Yeah,
fine.
Keep your carpet
Yeah,
cleaner.
there's yeah, no, I won't get
It's a
into that.
safety thing. The code cycle is going to pick it up. It's to protect toenails.
That's
If
right.
you open the door too close to your foot and you're not wearing a protective shoe, you need at least a 1
I
inch
can-
clearance to save
I
the
can
toenail.
I can so see that in the code book.
We'll get Glenn
That actually
Matthews in
sounds
on
like
that.
like a
He'll hop
local
right on it.
amendment. Local
That's
amendment.
right.
Oh my god.
Yeah.
That
Well,
might be my
yeah.
code proposal. I'm finally going to make one. I'm excited about
Lot-
this.
Lobbied against by the Podiatrist Association of America.
That's right.
Yeah, I think you want to undercut doors enough so your cat can stick their
Yeah.
paws through, which is a lot like in agriculture. You want to prune fruit trees so you can throw a cat through the tree. That's the official standard for how to prune a fruit tree. So you want to,
How
trim
big
your
of a
doors so
cat?
Yeah, I was gonna say cats come in small, medium, and
that- well, it's not an exact recommendation. It's just
Okay.
order of magnitude.
Oh my.
Or that was great, Doug. Thank you. Did you have a presentation, Randy, or some
I do.
slides? Or
Yep, we'll see if I can load this up.
yeah. While you're doing that, Josti asked, do door undercuts have a significant noise impact? They kind of do, depending on other features of your house. If you have carpet, not much of one, but if all the surfaces are hard, it really increases the transmission.
Sound transmission.
We have clients have us put threshold pieces in when they don't want to hear what's going on in each other's bedrooms.
What happened to turn up the radio? Come on, man.
What are you seeing? Anything?
I see. a
Yeah, we got your
desktop.
whole screen.
We see
Yeah,
your
hit-
whole
hit-
screen.
Hit the
You
play
have
thing.
so
and
many
it'll
tabs.
probably
I have
work.
anxiety.
Oh
That
my
one?
God!
You want that one? How's that
I
one?
love all the infrared
That's
photos.
beautiful.
that's a
No.
lot of FLIR right there.
That's
In
what
the
happens is-
bottom sort of right, Randy, the thing that looks like a chalice should play your slideshow. One to the right. Nope.
to the right.
You're on your mouse. Keep going over. You were down on the bottom. That one.
Okay. There.
There you
that's
The
go.
holy grail.
Okay.
Fabulous.
All right. So you wanted to know what it's like to live in Minnesota. I took that photo yesterday. No, I'm kidding. That
Oh my
was
God, I believe you.
that was last January. The ASV or the Bobcat, if I can get it to play, is a this is a barn dominium project that I've written about in Green Building Advisor. Again, last January this was started in December. So of course we've got to remove all the snow that we had up to that point before we could start insulating. So we managed to get a couple machines in to get the snow out, but then we still had 2 inches of ice underneath the snow that we, and this was all happening with temperatures hovering around 0. You know, our highs were maybe 5 to 10, lows were up to 30 below. So we weren't going to melt ice naturally. We had to try to get some heat in the floor, which took a lot of energy to get rid of all that snow. Picture on the left is it's a log cabin that I've worked on off and on for. I've showed that picture quite a few times on Instagram. Almost ground coupling ice dams, and that it's weird with ice dams. You don't see that every year. I was at that project this past year, and there were hardly any ice dams off that side. And this year that I took that picture happened to almost ground couple. All right. So this is something I see every once in a while. Cold climate, of course, cold climate, we get to see all kinds of weird things that can happen. The picture on the left is a good friend of mine. That was his window. It was about a 15-year-old window. What happens with that is the seal between the 2 panes break. And this one happened to have the blinds pulled overnight. The window gets a little bit colder. It happens to become a dehumidifier, pull all the moisture out of the area and deposit it on the window. Picture on the right is actually a failed seal. That's what it looks like, thermal imaging. I get to see thermal imaging that every couple of years or so. How do you fix that? You know, it's not, you just can't pump new gas into the window seals or anything like that. You've got to replace the either the window or the glass itself to correct the problem. This is a brand new sliding patio door of a major manufacturer, fairly expensive as domestic manufacturers go. It's a fairly expensive unit. I happened to be there doing a blower door test just to see how things were working, and you can see the air leaking alongside between the fixed panel and the operating panel of the sliding patio door. I have yet to see anything from this manufacturer that didn't have this outcome, which is unfortunate because, like I said, they are a major manufacturer in the United States. A couple of I have tested a couple of other manufacturers that I did not see this. It's tough to fix. You either call the manufacturer and say, hey, what can we do? But it's kind of again, with this manufacturer, it's kind of the way that their seals are working. They're just not designed the way they should. So what do? You replace the entire unit, you know, you try to do some kind of an aftermarket thing that's not going to hold up very well. It's tough fix.
Right, Randy, can you give us a hint? Just like, what's the first letter of the manufacturer? I don't want to get you in trouble, but just, I'm curious. Is it a W? Is it an M? Is it a?
let's say it's they're native to Minnesota. We'll do.
Gotcha. Perfect.
This window is not native to Minnesota. This is a brand new, again, in a brand new house, brand new window, and you know, sometimes they can have problems. Again, during a blower door test, it was leaking some air. It was locked. It was closed, but something was up with the seal. It just wasn't operating the way it should. This house happens to be on Lake Superior, and that is a north-facing window. So every time in northern Minnesota, the wind comes out of the north across Lake Superior or across the bay here, it's going to get a little breeze on that window. And of course, you can call the manufacturer a new window. They should warranty the issue with the product. Either send some field tech out to correct it or replace the unit altogether, depending on the cost. So Ben's got one of these too. I saw his Instagram feed. I got a new thermal imaging camera from Hick Micro. It's not that expensive of a unit, and they shoot video. It's the first thermal imaging I've had that's had the capability of shooting video. This house has severe ice dams in the winter. Both thermal imaging. I'll show the video on the second one here in a minute. You can see there's a pretty good connection to the attic. This was done, I don't know if the date's on here. I think it was in July. It was a fairly warm day for Minnesota. It was in the 80s. Of course, the attic is very hot. Under negative pressure, we're pulling in warm air from the attic space into the home. So we get to see all these pretty colors.
That is so awesome. I need a new camera.
I'll have a review coming out in FHB here soon about this unit. It's awesome for the money.
Good.
I was going to say, which one is this, Randy? Because you had a C5, but this doesn't
I
look
did.
like that.
I still have the C5. This is the Hit Micro Pocket 2. And it's actually cheaper than the C5.
Wow.
But it's new. It came out, I think, this spring, right, Ben?
Yeah, a couple months ago. It's twice the resolution of the C5 and
Yep.
$100 cheaper and
Yeah.
better operating controls.
Yeah, it's a cool camera. All right. So of course, in my climate, sometimes the homeowners take it upon themselves to try to bring comfort to the house. This way, I had nothing to do with this house. I happened to be driving by, and I had to stop and back up and take a picture. Homeowner decided to take the window out of their home and install a sheet of OSB. It looks like they maybe have some clearances around the OSB, so it's not going to start on fire with that chimney pipe. But they got the chimney pipe supported with a piece of wood, and whatever you got to do, right? Unfortunately, it's a little uncommon. It's not uncommon in my climate for homeowners to do whatever they can. They can't afford the heat, or they'll do whatever they can to try to maintain comfort in the structure. So I had this discussion with Jake Bruton a few weeks ago. So is that, what do you think that is? Is that, of course, cold climate, this car wash is, I took this picture is midway through the winter. Obviously there's some moisture moving through the cinder blocks. But what's the mechanism? Is that diffusion or is that capillary? I'm pretty sure it's capillary is my thought. Do you guys have any other thoughts? I mean, it's obviously car wash. It's very, very humid inside. We got a very, very cold outside. We got a vapor drive. But which way is that? I got to thinking, and actually Jake asked me this several months ago, had I ever seen true vapor issues where it's just, it's a vapor problem, not an air problem? Have I ever seen that in my climate? I can't say that I ever have. You have, Doug?
Yeah, in summertime.
Summertime, yeah. I for some reason, if I have seen it, I haven't recognized it as such. And I'm not sure if this was a diffusion or capillary. If anybody else in the audience has an idea, I'd be happy to hear it.
I just assume these were sweat stains from Jake being in the car wash. He kind of runs a little bit damp. He's just sort of a musty guy, and I figured it was efflorescing as a result of his perspiration. Is that not accurate?
Yeah, it could be.
Yeah. We see vapor failures in really old houses around here, 250-year-old houses that have dirt basements, and just the humidity level rots out the floor system.
Okay.
So it's strictly vapor.
Okay. Yeah. All right. So what's this? Again, thermal imaging, negative pressure in the house. Combustion air vent. Something I see every once in a while. It's not that often that and this is new construction. This was a brand new duplex. And for some reason they decided they had high efficiency forced air gas furnace put in, which of course used outside air for combustion, but they decided to put in the cheap water heater. And it's a small mechanical room, and it required the makeup air system for it. Now, blower door testing, you cannot plug that. That's open all the time. So if you're doing a code compliant blower door test, that needs to stay open. The vent on the water heater needs to, the exhaust port on the water heater needs to stay open. It's going to affect the blower door score of the house. If you're building new, you're trying to make it something tight. Don't use one of these. Put in an electric, air source heat pump water heaters can be great in some climates. They're a little rough in mine in the wintertime, but they do make the dual fuel where you can switch over to straight electric if you need to, or steel combustion. If you're going to go gas, put in a steel combustion unit, on demand, whatever. Get rid of these low efficiency units. So this was again, a new house, code compliant blower door testing. The house passed. This is a space over a garage. And the homeowner was planning on finishing it down the road. Of course, I needed a blower door test. It was part of the house, so it needed to be included in the test. I walked up the stairs to this, and my hat just about got blown off my head. There was so much air coming out this doorway. And here I found this. That wasn't the source of the air. The air was actually, because there was so much connection with the attached garage below it, that wasn't helping. That was going to be a problem down the road. But this builder, for some reason, didn't air seal correctly between the two spaces, and was pulling a lot of air through the garage up into here. But again, it's something that I see occasionally, these closed cell spray foams. I think I got a slide coming up. That's another one of these. So this is another brand new house. The house was almost done, and the siding was going up, and they realized that these wires were in the wrong location. So the carpenter knocked a piece of this is a veneer stone that was on the exterior part of the house. They knocked that off, dug out part of it, and you can see that gap on the right hand side of the closed cell spray foam. I was talking to the one of the builders. He was just a contractor, or an employee of the contractor. He was just in there doing his work. And he said, yeah, last winter the spray foam contractor came in, they spray foamed everything. We saw a lot of that, but we didn't say anything. Kind of going, oh, okay, this is a $2.2 million house, and it's going to look like that. What's it going to look like in 5 years? This could be a big problem. I haven't blower door tested this house yet. I was supposed to. The siding contractors had a lot of work to do. I haven't been back to it. I haven't been invited back to it, so I'm not sure what's going to happen. But I would be interested to see what the score was on this one. The other thing that happened with this, they had a very large exhaust range hood that was going in. They said that they were going to put some kind of limit on it to only allow, they didn't say how many, but to limit the CFM that was going to leave the home with that operating. Right across the room on it was a custom built fireplace. And the fireplace, the homeowner did not want doors on it. This is rural. By code, it can't be that way. The contractor gave in. They allowed it to happen. There was no inspections on that portion of it, so they just let it slide. And of course, I'm thinking, what's going to happen the first time they have that exhaust fan running and they go to start that fireplace? Is this going to backdraft? Are they going to burn their house down? So we'll hopefully the contractor gave them some education, maybe crack a window. There was no makeup air as far as I know for that system. That was another question I asked. They said they weren't planning on it, so could be an issue.
Well, the good thing, Randy, is most of those range hoods don't vent nearly as much as their nameplate says they do. So we've got that working in our favor.
Yep. Yeah. The issue with this one, it was a direct vent right to the outside. There was no duct. It was very, very short duct. 190, and I think it probably wasn't at the rating, but it was going to move some air. I think it would have been a problem.
Well, yeah, and as it cools off, the fire dies down and they all go to bed. They just won't notice that
Exactly.
It's backdrafting all that carbon monoxide. It's totally
Exactly.
fine.
Yeah. So this is, if you follow me on Instagram, this is the concreteless slab and grade house that I was involved with a few years ago. This was during construction. It's got an HRV unit, and the HRV hadn't been installed yet. We were finishing the interior. There was quite a bit of construction moisture, And that just happened naturally. We had a fairly windy day. This is a lake property. We had the wind coming directly off the lake, blowing across the side of the house like that. That warm, moist air coming out of the open tubes, basically the open ducts for the HRV system, and it scattered across the wall. I thought that was a pretty cool picture. Not something I see very often. How do you fix that? Of course, install the ductwork or install the HRV that get rid of the moisture. So this is another thing I see a lot in my climate. Everybody likes to have these conditioned garages, and of course, in my climate that means they're heated. And in Minnesota, you tend to, if you've got a vehicle, you're driving it around, it tends to accumulate quite a bit of snow and ice. I'm sure in Maine, you guys probably have the same problems, or New England, you see that quite a bit. You pull into your garage, you shut the door, you go in the house for a while, and of course the moisture off the cars are going to drip onto the floor. A lot of these systems are radiant; they're hot water in the cement, so they're heating the car's heating nicely. They're evaporating that water, but that moisture a lot of times has no place to go other than it builds up in the garage. A lot of the houses aren't connected or have a pretty good connection between the garage and the house. We end up seeing some moisture migrate into, but a lot of times the cold surface or the surfaces that can get very cold will become condensing. Of course, the garage door rails and steel, you can see that's an insulated, the picture on the right, that's an insulated garage door. But the aluminum or steel, whatever that is, transmits the temperature very well, and it collects the moisture out of the air. Same thing with the lock set. Cold enough, direct connection to the outside, and it's condensing, becoming a dehumidifier. I do have an article that I wrote. It appeared, I think, last December on conditioned attached garages and the importance of not only eliminating that connection between the house and the garage, but dealing with the moisture, first dealing with it in the water form, and then trying to deal with it in vapor through either you're running a dehumidifier is often what I see. HRVs are another option that I see quite a bit, just to try to get rid of that humidity in the space. And of course, the HRV has to be dedicated for the garage. It cannot be one that's shared with the house. And again, that's what we see. You can see the temperature range on the right-hand side. This is my FLIR. I think this was the C3. I have a C3 camera as well. But it looks like the garage doors are on fire. They actually aren't. The temperature range is 18 degrees to 1 degree. So it's not a huge temperature differential, but it still looks impressive on a thermal image. The very bottom of that, you can see the slab where it's outside of the garage doors and how that's even warmer. And I do see that a lot. You end up losing quite a bit of heat out these heated garages through that exposed concrete on the exterior. Yep, if you can see daylight, often there's a problem, even in the attics. This is a moisture issue waiting to happen. But you can see the Tyvek. The sheathing is probably the siding in this case. I don't remember when I took this picture, but you can see the house wrap comes up midway through the attic, or this would be an unconditioned attic, a vented attic. This was pretty common in my market. I remember seeing this a lot when I was working as an electrician. We'd drive by a garage or a house, and they would only extend the house wrap up to the area that was heated. A lot of times these gable ends would be left unprotected, and this is one of those cases. Of course, fixing this, you have no sheathing, of course. So how are you going to rip all the siding off? And yeah, it's not an easy fix. It's not a cheap fix to do the whole house to repair it. Or you take off just a little bit and extend the house wrap up. I guess that would take care of it too. Hopefully I don't get in trouble with this one. This is my neighbor's house, and they happen to be re-siding, and I took a picture. It shows stack effect pretty well. This is an early manufactured house. I'd say that this house is probably from the early 70s. It was hauled in and set on a foundation. I think it's just got a crawl space underneath it. There was no sheathing. The siding, you can see the picture on the left there's a little bit of the siding that was remaining. That's what was the sheathing and your air barrier, and it wasn't performing at all. But you can see how dark the insulation is at the lower part. Of course, in Minnesota in the winter, we get stack effect. We want to draw air in on these lower areas, and that the insulation was acting as a filter at the bottom. And I'm sure if I went up to it, pulled some of the insulation away at the top, it would probably be dirty on the interior side at the top of the structure. Again, it's interesting what Minnesota weather can do to a house, or Minnesota climate does. Corners are a little bit, that picture to the right is you can see the dirt in the corners. I'm assuming that's a wind effect. The corners can take a little bit more of a beating than the field of the house for wind moving, especially in a house that doesn't have any sheathing. It just has that lap siding as the air barrier. So yeah, another fun picture.
Is that a permanent wood foundation?
No, I think on the other side, I think it is block, I believe. We do have quite a few permanent wood foundations though in our area.
I like that it's the only foundation called out in the code that has permanent in front of it, as if the others are temporary. Like, I got this temporary concrete one over here, but let's try this permanent wood one. It'll be way better.
Yeah. Good
code language.
Yep. So again, houses that the homeowner has comfort issues. This was a homeowner fix, of course. Hopefully a contractor didn't go in and try to do this to somebody's house, but probably the cheapest thing you could do, I guess, to fix the problem. It'd be better if you could pull some of that vinyl siding off and maybe address the holes that all that stuff is created going through.
A contractor would have trimmed it flush when they were done.
That's right. Yeah. Or at least spray painted it to make it look like it was the same color as the siding. Yeah. So this is a house that I was working on. To stay busy, I can't do building science and energy audits all the time to stay busy in my little tiny market. So I do custom tiling, and I happen to be in this house that was being remodeled. This was in the kitchen. They ripped the old kitchen cabinets out. They were going to replace them, and that the left-hand picture, the right-hand side of it, somebody, the electrician probably came in. They needed to add some wiring, so they cut the drywall apart, ran their wiring, and then they just smashed the cabinets into that spot, put the countertop on, and called it good. Well, I got called back to this house 2 years later. After this, the contractor that was fixing it, I brought that up. Of course, nothing happened. They just covered it up the way it was. This picture on the right is actually just on the other side of that hole. And this was in October. That's moisture that was between that house wrap and it's got board sheathing on the outside. So that hole actually, even that early in the winter, was moving some moisture somehow through that opening and into that wall where it was getting wet. That was a really early house wrap. I'd never seen this one. I can't remember what it was called, but you can see the punched openings in it. I'm pretty sure it was around the time that the early Tyvek came out. And the builder that was doing the siding replacement, it was in good shape. So they just left it on, and I talked them into putting some rain screen on, and I told them they should have fixed the hole on the interior when they had the chance. And I don't know what else to do.
That's really common around here, cutting stuff out, especially in kitchens when it's in the way of the countertop or the whatever.
Yeah, if you look close at
dishwasher,
there's a that's a poly vapor retarder that was in place, and they actually cut through that as well. So.
Yeah, the house has to breathe anyway, so what's the problem?
Yeah, That's what happens when houses have to breathe too in a northern climate. You end up moving some of that moisture into the attic space. Both these pictures were taken in days after it had warmed slightly, enough to turn that frozen stuff that was in the attic back into a liquid form. It managed to run down to the soffit where it found a place to get out. Again, fun pictures to take. The homeowners usually aren't that happy when I tell them how they got to fix the stuff. It does get complicated. But yeah, it's again a common event in my climate. Yeah, and this may be happening all over the place. It's just it doesn't have the same effect. You know, you don't get this ice that builds up in the attic spaces in Doug's climate, for instance, or Travis's climate. You might get some, but not to this level.
I don't have
Literally
it like
never
that.
seen ice in an attic. Go ahead, Travis.
Oh, I see it on the back of sheeting, but I've never seen it dripping out of the soffit vents before. That's pretty impressive.
Never even seen it on the nails or anything. Too
So
warm.
that's what happens when it's an extreme, when you catch it before it completely melts.
Before it becomes a death sickle.
Yes. So what happens with this is when the air, it's actually an air leak in the attic, and that air leak is dragging a little bit of moisture with it. The roof deck gets very cold. The first thing that condenses are the nail heads that poke through from the shingles above. Those start forming frost first, and as the roof continues to cool, the plywood sheathing gets cold enough to eventually frost entirely. And then this house happened to have some freeze thaw cycles where some of that had melted. You can see that the homeowner pulled the soffit down, and it actually formed icicles in the shape of the soffit after he got them pulled out. Right above here, this window that's here is a bathroom window. There's a bath fan in it. And the weird thing is that this house has got a vaulted ceiling, but right below the vaulted ceiling inside this bathroom, it's got another ceiling. So the air is actually moving through two ceilings to get up into the space. There's the bay that's really messed up. There's a bath fan that penetrates through the roof. And I think there's a leak in the ductwork that was forcing a lot of that moist, warm air into that space. I don't know exactly how it was transmitting between, it was getting through all these stud bay or the rafters. It must have been just enough holes through there for some of that moisture to move between the spaces. But again, cold climate.
Yeah. Right. Randy, you have like 9,500 or 10,000 heating degree days. Is that about right?
Yeah, International Falls, which is about 100 miles north of me, is pretty close to 10,000 or maybe just over on typically. I've seen us under 9,200 a few times. I try to track that just to see where we're at. Last year, I think I tracked 9,700. It was pretty chilly last year.
Okay.
You get to Duluth, which is about an hour east of us, and the climate's again a little bit different because of the big lake. It changes things a little bit. And then you get to the warm area, the Twin Cities area. That's it's tropical down there compared to. It's surprising with 3 hours, 180 miles north, how much it changes.
Yeah.
They're in climate zone 6 down there.
Okay, yeah, and just in comparison here in Maine, we're climate zone 6, so we're like 7,200, 7,500 heating degree days, and Travis and Doug are probably like in single digits.
Doug posted 3,900.
3,900.
Yeah, that kind of single digits.
That's basically single digits to us cold climate.
Let's talk cooling degree days though, huh?
What are
I have
those?
400
Oh, wow.
cooling degree days. Yeah.
Well, ours used to be 1,200, but I don't think it's that way anymore.
So again, I posted this again, what you see in the wintertime in Minnesota. Hate to say it, but this is my house. I've been working on the siding, and you can see I've got Henry Blueskin up so far. But you see where all the water is leaking out is above that. The house has got tar paper. It's got a just it was built 1952, so I've got board sheathing behind that. Those two windows are both bathrooms, and I tested my bath fan. It looks like it is blowing pretty good outward, but there could be a couple of leaks. I haven't taken the ceiling down just to make sure. There could be some moisture that's getting pushed out through that bath fan into that rim joist area where that's creating the problem. But above that too, the window above it, there was some ice that I had coming out this window as well. You can see some frost buildup. This is an older window, might even be original to the home. So yeah, I've got still some work cut out for me on my house. So I could see a lot of log cabins. It's funny how these were really, really popular, 80s, 90s, even through the 2000s. There were 3 or 4 pretty big log cabin builders in our area. I don't think any of them are in business, or if they are, they're not doing very many. They're not doing that much work anymore.
They moved to climate zone 4.
They could be. They like to stick their these big logs through the wall assemblies. Of course, they go all the way inside. They transfer heat. They can't get them air sealed right. The ceilings are never connected to the walls very good. There's always leakage points. I've got some more pictures of that condition. But yeah, they're really, really tough to work on. How do you chink? Are you going to chink the whole cabin to try to make an improvement? It's tough. Anybody that works with caulk all the time, imagine going through, spending the next 6 to 8 days going around a log cabin trying to seal up every little crack. Okay. Again, the ceiling stuff, where it's always in the it seems like most of the problems are in the attic or the roof systems where they really can't get a good seal. Walls occasionally also. The repurposing of a hole. Again, this is my house again. Isn't that nice? So I think my house originally was heated with fuel oil. And at some point they brought natural gas in, and that was just the easy way to get it in. When I first moved in, I had found a couple of voles. They weren't mice, but they were smaller than mice, the funky nose on them, running around the basement. Got them, sealed that up, and took care of the problem. I've noticed that, and I have done the majority of the exterior low. I don't have nearly as many bugs in my house anymore. The lower, the basement. The spiders are rare, which helps out a lot. And this is also my house. In 1952, I got a cape house, so I've got this nice attic space that doesn't know if it's inside or outside. Somebody came in I think it was remodeled in the 1990s. Somebody came in and put another layer of drywall over all the wallpaper, and of course I was remodeling this area on the interior. I pulled the first layer of drywall off and I saw this. Ooh, that's cool. I can take a picture of that. You see the water staining coming down. Just kind of wondering what the original homeowner in 1952, 55, 60, every spring, their roof would leak and they'd have all this water running down the interior of their walls. But it is air leaks. My house is at about 10 air changes per hour with the blower door, 50 pascals. And it's all in the roof. It's the majority of it. I've addressed, I've got Henry blue skin on my board sheathing now, on most of my board sheathing, which is helping to tighten walls up. Here's my last one. I'd like to show off my house. So this was 2 years ago. I woke up, this was 4 o'clock in the morning. I woke up to this smell in my house. I ran downstairs. I saw that. The first thing I had to do was go get my phone so I could take a video of it. Make sure that got on Instagram.
Priorities.
Yes. Yeah, that was a little bit, and of course that happened in February.
Always.
On a Friday. So we're scrambling to try to find a replacement furnace before the house froze. Yeah, it was fun day.
What'd you do?
I found a replacement furnace. Luckily, my brother, he owns a really good company called Williams Septic and Electric. and he happens to have accounts for, he does a lot of heating systems, not gas usually they're electric, but he has an account with a distributor where we were able to get a furnace real quick, and he helped me pop it in. By mid-afternoon, we had heat back on.
Interesting. That's exactly how mine killed itself. When the heat exchanger cracked, it blew the flames out the front and melted the wire and turned itself off.
Yep.
Yeah.
Yep.
A noble death.
You
Yeah, I
made
ran
that
out to
comment
Home Depot and I bought like 6 little electric heaters. But I don't live where you live.
Yeah, I would need about 30
Randy,
of them. Yeah.
you made that comment about less bugs in the house, and it reminds me of a trick that I learned years ago to find air leakage in houses. You look for where the spider webs are,
Exactly.
because that's where they sit, because that's where the bugs come through and they can catch their meals. So easy way with even out a blower door or any test equipment to find air leakage is look for spider webs.
Yep. Yeah, I've done some testing on my house. I've got I rigged up a manometer that I have set up. I have a hose that runs all the way up. When the house was built, somebody put in one of the laundry chutes that go from the upstairs level all the way to the basement. So I ran a tube all the way up to my upper level. And I have another one that goes outside, so I'm able to monitor stack effect in the winter time. And not on the windy days, that upper level, I've seen it go 12 to 15 pascals negative on a windier day. During the day, that the stuff that Doug was seeing with 5 pascals, that's pretty typical. 3 to 5, depending on the temperature outside, temperature differential. But that's amazing what a house will do with stack effect and wind.
Justy has a good question. If you're on the border of a climate zone, for example, Cincinnati is on the edge of 4 and 5, which climate zone details should he adhere to, or should you adhere to? Should you go with the colder zone, the warmer zone? Does it depend on the situation?
For me, I'd go to the colder one.
Yeah.
You're going to build a little bit higher standard or higher R values.
Right. Yeah. Are there situations where, with progressing climate change, as things get warmer, are there situations where that could backfire or not?
I worry about our climate. Minnesota is a poly state. It's still very, very common in new construction for poly to be installed on the warm and winter side. And I joked about not knowing where air conditioning is, but every new house up here gets air conditioning. It's what happens, and we start running them when the temperature gets to 65 because we're used to it being 50, or 30 below or whatever. So it is something that I worry about. I wish we would move away, or builders would understand that that's not a good assembly. Do something different. But if you're building a good house to what we're doing with the good building science that everybody here is trying to spread around, to teach, it should be good. Even if you move from a climate zone 7 to 6 or 6 to 5, you should still it should still perform well. Matter of fact, I asked Joe Stiebrick that question at IBS, BS and Beer, and he kind of said the same thing. Don't worry about it. So, yeah.
No, thank you. What do you think? Heated garages? I'm having trouble talking clients out of them, no matter how hard I try. What do you think are?
Let me try, Mike. Let me try.
Yeah, my vehicles have never seen a garage, so just I'm not a good example. And I've tried to think of like thermally broken slabs and this and that, but just like what's the answer? How do you do a better heated garage?
The temperature as low as you can. The differential. I personally would probably stay away from the heated slab because you are connecting to the outside. It's really hard not to with garage doors.
Yeah, I can't get away from it really.
Yeah. But keep it. You go with a forced air, some kind of a wall hung or ceiling hung unit. and try to keep the differential as close to the outside as you can. Even insulating a garage, you think of our climate where we might have 100-degree temperature differential between inside the house and outside the house. In a garage, if you can heat or just insulate the garage and make it airtight, not heat it, a lot of times, even at 20 below, the garage is going to stay above freezing. It's at least it's better than being 30 below or whatever. But yeah, if you can air seal and insulate it well, just do that. Tuck them into that. You can always add a heater later if they're not happy with it.
Right.
We've done like Modine heaters like Randy's talking about in a garage, and we try and set them on a programmable thermostat so they kick on an hour before the person's normally going to leave in the morning.
Good strategy.
So that, you get the benefits that they're after of getting in a warmer car.
Yep. We get people that are just, it's what they expect. They expect to have a 60-degree garage when they walk out of the house. And they're going to pay for it. I had one and I used it as my workshop. It would have to be attached. I had a boiler that was set up, electric boiler set up just for that garage. And I figured it was costing me $100 a month to heat. This was back in 2006, 2007. Of course, costs have gone up quite a bit since then. So just heating those is going to cost something. And then of course you got dehumidification, or if you got a dehumidifier in there, you can probably figure another $20 to $40 a month just for that. So,
This is a whole nother show, but as people move to all electric, you can turn your electric car on like half an hour before you leave. It'll be 68 degrees when you get in. It doesn't matter. You don't have to open your garage door. You're not really worried about anything. It's programmable. That's moved some of our clients away from heated garages. For the most part, we insulate them, but we don't ever heat them.
I'd even like to see them detached, even with a breezeway or something between to keep it out of the house. There's just, I've been in houses where I've had homeowners bring me into their closet and pull their clothes away, and there's a big moldy spot on the exterior wall.
Yeah.
Their clothes are acting as an insulator, and it gets cold there and it collects moisture. It comes a dehumidifier again. And I've been able to source it all the way back to the garage, even though it was all the way across the house. It's still the moisture from the garage was ending up in the house and was creating an issue. So yeah, if you can detach them, or even put an airlock between the two, if that's conditioned or whatever, just try to keep the spaces as much separate as possible. But I was working on a house today that it's attached. It's on the same level. You walk from the garage and there's no steps, there's nothing. You just walk right into the house. It's going to be a problem.
I always want to ask the client, what is your commute that the car remains in conditioned space? Because it seems like that might not be going on, and maybe you should just accept that the car will get cold at some point.
Yeah, but if it's too short in our climate, it never warms up. If it's too short, yeah. So you're in a car and it's 20 below. That's what it's going to be when you get to the job.
Your clients are aware that there are states further south than Minnesota.
We have water though.
Yeah, ours is just liquid.
Yeah, ours you have to bring in a boil to get it to thaw out. Yeah.
Oh man.
Well, and just quickly, a question I had that I didn't get to for Doug. What was the story with the BOA house that you inadvertently burned down?
Oh,
You don't want to close on that. That's terrible.
no, it's
Oh,
okay.
sorry.
It's okay.
This is scary building failures, isn't it?
Yeah.
Yeah.
So, yeah.
It was in the middle of construction. Actually, it was about ready to close in. So it was at the point when it's the most flammable and the most valuable. There was a party with 120 teenagers across the street. We had been finishing cedar siding with solvent-based finishes in the garage, which didn't have doors on it. Someone called in that they could see a fire in the garage, and the fire department got there, and there was some whatever. I don't even get into that. Anyway, the house was completely burned down. It actually damaged the foundation. Like there was nothing left. It damaged multiple fire trucks that parked too close to it. It was a pretty, I could see it from about 8 miles away as I was driving to it. It was a pretty bad fire. So the fire people that night, the investigators said that the most likely it was probably the solvent guys, like oily rags kind of thing. And then the insurance companies, multiple insurance companies, and the fire investigators all met and said, where are your oily rags? And our guy said they're in a metal can in the dumpster. And they went over and covered the dumpster with a tarp. And then they brought out like a bunch of attorneys and dug it up and found them. And then the fire investigators changed their thing from we think it's this to we don't know what it could be, but this is the only thing we can think of. Kind of whatever. I forget what the levels are. They have like all these different exact, someone who actually knows what they're talking about could tell you, but it went from like we know what it is to we really don't know what it is, but we can't think of anything else. Of course, the rest of it, all of us think it was the kids, those damn kids, but I have no idea what it was.
Somebody flicked a cigarette and it landed in the garage or something.
Yeah.
Yeah, who knows?
Wow.
They said that it could be spontaneous combustion of the actual wood with the solvent-based finishes on it, not like anything that was done wrong, just that catches on fire.
Wow.
We had a house that we spent about 1.5 years building and substantially renovating. That about 3 months after we finished it, the homeowner was oiling some woodwork in the basement and threw the rags into the garbage can, and spontaneous combustion of the rags took the whole house into the foundation.
Oh, you can definitely start a fire with oily rags. We've actually had 2 close calls on that this year, and I know one of our clients, their second home maintenance guy, burned his truck to the ground with oily rags in the back. Gotta be careful.
Well, water-based finishes are the answer.
Loba.
Yeah.
Well, I think that draws us to the end of our time. Excuse me.
Oh.
Sorry.
Okay,
He
bye.
like totally disappears. He's like, goodbye.
And we're done.
Yeah. No wasting
mic
anyone's
drop.
time there.
No, I think we owe Doug and Randy a huge debt of gratitude because
Yes.
showing us these failures helps us to not make those errors on our own. It's always helpful to learn from someone else's expense. So thanks for your lessons tonight, gentlemen. It's always a pleasure to see you. And thanks everyone who joined us.
Yeah.
Thank you.
Thank you.
Yes,
Both
thank
of
you very
you.
much, guys.
Thanks all.
It was really fun.
See you next
Great to
month.
see you.
Thanks for the chat, everyone.
See you in Kansas
Yeah.
City.
And then in Chattanooga.
And then in Chattanooga. And then in Austin.
However you spell it.
Yeah.
It's all the vowels and then all the consonants. We get them all. Thanks again,
All
guys.
right.
All right.
Yeah.
See you guys.
Thanks.
See ya.
Bye.